This morning we're going to look at some indexing best practices in MongoDB. And this is not a comprehensive list, but just a few items just to note when you're building an index. First one, or building indexes I should say, the first one is that consider the type of queries that will be used for your indexes. And what I mean by that is that the order of your indexes matter. And so if you're querying on one field, let's say field A, and you're indexing on field B, and this one may sound fairly straightforward, that index is going to have no impact if you're querying on field A and you've indexed on field B. You want to make sure that your indexes, it's very similar to SQL, and I see this a lot in SQL from time to time. People will index a field, but they never actually put that field in their where clause or in their joins, and so that index is basically just is worthless. It has no use. It's not being used. So make sure to actually index a field that you're actually querying on. And if you're not querying on any field, for instance, if you're going to select star from, especially in SQL, for instance, if you were going to select everything from a table, indexing doesn't have any benefit, right? It's not going to benefit you to index a table. If you're going to select everything from the table, you're going to select everything from the table. I'll give you a case in point. Yesterday, there was a developer that we had who wrote a query that used doesn't equal to, and we were getting some specifics whether it was supposed to be doesn't equal to or greater than. So greater than and doesn't equal to are not the same queries at all. For instance, in the world of SQL, one is sargable and the other one is not. And so that's something to consider when you look at indexing, is that, you know, what is the query going to run? And the person didn't think about that when they built it. Is it supposed to be doesn't equal to, or is it supposed to be greater than? When you're looking at the balance of what a loan is, generally speaking, as a case in point, you want to look at whether the loan has something owed on it, which would be a positive balance. Okay. Same thing in Mongo. Make sure that you're indexing the field that you're actually querying on. If you're not, that's not a good sign. Keep in mind, too, that sort operations will affect how you index. And what I suggest when it comes to these things is to actually do a lot of testing. Okay, there's no really official rule for indexing. You have to test every single thing that you do. Did that have an impact? Did it not have an impact? Why did it not have an impact? Then test it again. Test it with these fields. So testing is the second best practice of all. There's not really an official rule that you can just follow and it always works in every single environment. It's not going to happen. Third best practice would be to make sure that your indexes are compatible with your RAM, or I believe what the 10gen people say is that your indexes will fit into your RAM, basically. This is for basically fast processing. If you have 16 gig of RAM, then your indexes should never exceed 16 gig, right? It just shouldn't happen, okay? And you can, let's see here. Go here, and let's do db dot habs dot find dot pretty. Let's look at this, and then if we go to the db dot habs dot total index size, you can see the size of our indexes. Okay. And that is, by the way, for the record, that is reported in bytes. So it's not anywhere close to, that's nowhere close to that many gig. All right. So that's an example of something that you can look at. Is it compatible with your environment? Okay. You want to make sure that you have more than enough RAM to cover your indexes, and especially the ones that you're going to be using a lot. In fact, that's fourth best practice, I would say, and this is true with any environment, including SQL, is so what are your most common queries that you're running? And then finally, I would say the fifth best practice that I would suggest, and this one is also a big mistake, is that your queries need to filter. Select star is not a good query. It's well, select star from with no where clause is not a good query, I should say. Select star could be a good query, but with no where clause, it's not. Okay, what's the filter you're applying? There are very few situations, and when I say few, I mean probably less than 3%, where you actually need everything from a table without a where clause. So that where clause is going to dictate what's going to be indexed, just like your joins in SQL are going to dictate that. It's the same thing in Mongo. When you do, db.collection.find, in that find, we should see some type of criteria that's filtering those data. To find everything in a collection is kind of a problem. Let's just say, for instance, a lot of people they build their first MongoDB project, let's say, as a blog. Okay, let's take a blog for instance. I don't understand why anyone would grab everything from a blog collection when you're not going to pull up a blog page, just as a case in point, and see every single blog post that someone has ever written. You're going to see probably the first, let's say, 5 to 10 blog posts, right? And you're probably going to even see just a snapshot of those blog posts. So that's an example of how you're basically finding and you're limiting 5. Okay, and then when someone hits more, it may produce more. It may load a few more. But the idea is that I don't think it's a good notion to sit there and to throw out a query that selects star and selects every single thing. So you don't really allow your environment to have high performance if you're going to select star from a table. And even in stock data, let's say I was looking at the SPY, outside of charting, and yes, it is true in charting, but consider that in charting we're just looking at the price over time, so we're not even selecting like the 200 SMA or any of that unless we wanted to add that. But consider the fact that most of the time people can't look at a table full of every single value throughout history. So they're going to be going to the next page and the next page, and so that will be the next query. Okay, so that would be something I would highly suggest is if your query is select star, you probably don't understand everything that your client wants, and really consider putting some type of filter in that find clause. That find clause is going to be, it's very similar to that where clause in SQL. It's select star from without a where clause is a concern. Okay. Now, one thing I will note about that. The exception to that rule in SQL Server and the exception to that rule in Mongo is suppose you have a collection. So you start at one collection and you copy to a new collection, and in this collection here, the one collection, let's say up here, you filter it into the second collection down here. You already applied your filter, then you select everything from the second collection. True. Same thing with a stored procedure. You might have a stored procedure which copies a data set to another server and do all your filtering in that stored procedure, then you'll select star from that table. Makes perfect sense because you've already done the filtering process. Outside of that, in a pure data set, and if you think about that from an ETL perspective, and my students who are in ETL will understand this as well, is that you are going to filter all of the data that you don't want to get into the final main data set. So yes, that final main data set you might select star from, but that's because you've already filtered all of the data that you don't want in there out. So that is the end process of all of that filtering. The key, though, is that there's filtering before you select everything from a data set. And believe me, I've seen 10 billion rows of data turn into 100 million rows, because that's how much data was removed over time or how much data was filtered out.